Hello dear students, today in this video we are going to discuss about how to balance a chemical equation. So yesterday we already discussed that how to write a chemical equation. So chemical equation actually represents a chemical reaction. So what are the things that we just talked about yesterday? So just we need to recap. So in a chemical reaction, so a lot of changes are happening. So one substance loses its identity so as to form a new substance. So that is what happening during a chemical reaction. So is there a way of representing these particular chemical reactions? So first of all we are looking at, suppose you may all know that the formation of water. So what are the reactants that are taking part in the formation of water? One is hydrogen and the other is oxygen. So we will represent just by using the word equation, the chemical equation. So it can be represented in the form of words using the exact name of the elements or the compounds formed as a result of the chemical reaction. So in this way we can write or represent a chemical equation. So this kind of equations, they are using the exact name of the elements or the compounds in their form. So that kind of equation is called a word equation. So you may just look at that this equation, it is very lengthy. So it is not that much appropriate. So it will take so much time to write down the exact names of all the elements, compounds, whatever are taking part in the chemical reaction. So what we have to do now, we have to write. So it will be better if we write, if we using the symbols of these elements. So example, hydrogen. So we can represent what is the symbol for hydrogen? H. So symbol for oxygen is O. And similarly, the chemical formula, the molecular formula of water, that is H2O. So we all know that. So why can't we represent a chemical equation using these symbols of elements or the chemical formula of the compound? So it will be more easier for us. So such an equation, so that can be represented in the form of using symbols of these elements and compounds. So such an equation is called what? Chemical equation. So this is called word equation and this is called a chemical equation, and it is also known as a skeletal equation. So why I have written here skeletal equation? This equation is called a skeletal equation. So last year, let us go back to the last year. So what we studied there, we studied there are two laws of chemical combination. So one says that the first one is saying that the law of conservation of mass. So in that law it states that mass can neither be created nor be destroyed during a chemical reaction. So that's a proven law. And similarly, the second law states that, which is law of constant proportion, it states that the atoms take part, the chemical elements or the elements which are taking part in a chemical reaction, so they react in a certain definite proportion by mass, so as to form compounds. So first of all we are going to look at how this particular law, this cannot be disproved. These laws are already proven. So we cannot write an equation which is unbalanced. So in chemistry, whenever we write a particular chemical equation, so in order to obey the law of conservation of mass, we need to balance a chemical equation. That's why we are studying in today's topic how to balance a chemical equation. So now let us see. So hydrogen. So why I have written here H2? So we already studied last year that the valency of hydrogen is 1. So similarly, hydrogen is also a gas, so which is a diatomic molecule. So we all know that. That means two hydrogen atoms combine so as to give one molecule of hydrogen. So H2. So we are normally representing gases in the form of molecule. That is why I have written here H2. And the next one is oxygen, O2. So why I have written here 2? The same reason, valency. In order to, oxygen cannot exist in the form of monatomic gas. See, here oxygen is also a diatomic gas, and it is also existing in the form of triatomic gas, which is also known as ozone. So similarly, so these two are the reactants. So that are written to the left hand side. Here you can see, and as a result, when these two combine, so as we are getting water. So in order to prove the law of conservation of mass, so what is saying in the law of conservation mass? Total mass of the reactants. Last time we already did so many examples. Total mass of the reactants must be equal to total mass of the products. So here, if that is the case, the number of atoms on the left hand side must be equal to the right hand side. Clear? So here we can look at now hydrogen. This left hand side hydrogen, number of hydrogen is 2, and the right hand side is also number of hydrogen is 2. So if we want to balance a chemical equation, so you might have seen merchants, they are weighing the things. Suppose if you are going for purchasing 1 kg sugar, so they will put 1 kg weight on one pan, and the amount what we are asked 1 kg. Suppose they will keep that particular amount, they will try to balance that particular balance in order to give the exact amount what we required or what we are asked for. So here also we are doing the same thing. So imagine the things which I have written to the left hand side of the arrow mark, that is called the reactants, and what is coming to the right hand side, that is called the products. So the mass of these two parts onto the left hand side and to the right hand side, that must be equal. So that is what is said in the law of conservation of mass. Mass of the total mass of the reactants must be equal to total mass of the products. Then we already discussed about atomic mass, molecular mass. What is atomic mass? Mass of an atom. So what is molecular mass? Mass of a molecule, or total mass of the atoms present in a particular molecule. So we already know how to calculate the atomic mass or molecular mass. That part we already discussed in last year. So just go back to that particular topics again, and you practice 1 or 2, and then come back. So here, so if the mass on either side of this equation, if that is to be balanced, then the number of atoms existing on either side of this equation must also be the same. So in order to do that, we can do one thing. So in order to make oxygen, the number of oxygen atom on the left hand side is 2. In order to make the same on the right hand side, if we write here 2, that will be wrong. So why? So H2O2, that is another compound which is called hydrogen peroxide. So we are not allowed to change any subscripts that are written H2O. So we cannot write anything here in order to balance a chemical equation. So instead what we need to do, we can change anything what is written onto the left hand side or called the coefficients. So first let us see, number of hydrogen atoms on the left side is 2, on the right side is also 2. Here oxygen atom, number of oxygen atoms on the right hand side is 1, but to the left hand side is 2. So here we need to add 2, that 2 we have to put here. So this 2 is common for both hydrogen and oxygen. So now number of oxygen atoms on the right hand side is 2, and to the left hand side is also 2. So, but while doing so, what happens to the hydrogen atom, the number of hydrogen atoms? Yes, it is increased to 2 into 2, that becomes 4. Onto the right hand side, the number of hydrogen atoms became 4, and to the left hand side only 2 is there. So we are putting just 2 over here. So now we can again count the number of atoms to the left hand side and to the right hand side. Here you can see 2 into 2, number of hydrogen atoms 4. On to the right hand side also 4. Oxygen here 2. This 2 also applicable for oxygen also. Number of atoms on to the right hand side also 2 oxygen atoms. So in that condition, you can rewrite this particular equation, that is 2H2 plus 1 2 gives 2H2O. So here in this equation we can see on either side of this atom the number of atoms remain the same. So we can write what this equation is balanced. So we need to do some kind of adjustments in order to make the number of atoms equal on either side of this equation. So we are just trying to write 1, 2 or 3, any number if you put in a logical way. So this kind of technique that is called hit and try method. So we will practice one for the next equation, zinc plus sulfuric acid. Zinc, when zinc metal is put into sulfuric acid or hydrochloric acid. So what is the product for zinc sulfate and H2? So look at this equation. On the left hand side we have got 1 atom of zinc. On the right hand side also 1 atom of zinc. Then to the left hand side 2 atoms of hydrogen. On the right hand side 2 atoms of hydrogen. Sulfate, sulfur 1 atom. Here also 1. Oxygen 4. Here also 4. So this equation is a balanced chemical equation. Now let us look at another equation. It is given in your textbook. You follow, go through all the steps which has been explained in that particular page number 4 of the textbook. Look at this equation and write down that particular steps in your copy and follow this video so that we can understand this particular topic well, clearly. So let us look at this equation. How to balance this equation? See, here you can see this is the left hand side must be the number of atoms onto the left hand side must be equal to the number of atoms onto the right hand side. Here you can see now first of all for balancing, so this is first, in the first look you can see 3 atoms of iron to the right side, to the left side only 1 atom, and similarly you can see oxygen, number of oxygen atom is 4 to the right side, but left side only 1 oxygen atom. So here you can see 2 atoms of hydrogen to the left hand side and 2 is already there to the right hand side. So what we have to do in order to balance, make these 4 atoms of oxygen over the right hand side. So here what we need to add here 4. So the number of oxygen atom is now balanced on either side of the equation. Clear? Now while doing so, what happens to the hydrogen here? Number of hydrogen atoms in H2O. So that became 4 into 2 became 8. So in order to equalize the number of hydrogen atoms, what we need to do? On the right hand side only 2 are there. Here 4 into 2, 8 atoms of hydrogen. So what we need to add here? Yes, 4. So now the number of hydrogen atoms is also balanced. Now what is remaining? Fe3. 3 atoms of iron or ferrous. The chemical name of iron or chemical symbol is Fe. That comes from ferrum. Ferrum, that is a Latin name. Okay. So what we can do in order to make the number 3 or the left hand side, simply you put here 3. So you cannot put 3 over here. Clear? So 3 atoms of iron that contains when it reacts with steam. So actually this particular H2O that is in gas state or the steam state, when iron metal reacts with steam so as to form this Fe3O4 ferrosulfuric oxide plus hydrogen gas. So now this reaction or now this equation is also balanced. Here you can see hydrogen will be released in the form of gas and this will be the solid product, and iron, as you know, which is also in solid state. So we can make the equation more informative by adding the states of reactants, the physical states of the reactant, whether it is in solid state, liquid state or gaseous state. So we can add this kind of information so as to make the chemical equation more informative. And similarly, we can add few more informations like that the temperature at which this particular chemical reaction happens, or the pressure what is required for carrying out a particular chemical reaction, and in addition a catalyst. Suppose in order to increase the rate of the chemical reaction, sometimes we need to use catalyst, which are actually the substances that are increasing the rate of chemical reaction without actually taking part in a chemical reaction. So that can also be represented over this particular arrow mark. So either pressure can be represented at what pressure that happens in the case of when gaseous reactants are participating in a chemical reaction. Then temperature or the reaction, these are called the catalyst, presence of catalyst. So these are the reaction conditions, so that are essential for carrying out this particular chemical reaction. So that also can be represented either above or below this particular arrow mark, so that we can make this chemical equation more informative. And similarly, you can see we can add additional informations such as this particular reaction. If you look at this particular equation, so whether it is feasible or not, that doesn't matter. So we are balancing. Once we balance this particular chemical equation, last week we studied about mole concept. So here we can see, here this 3 represents 3 moles of iron reacts with 4 moles of water, so as to form 1 mole of phosphoric oxide plus 4 moles of hydrogen gas. So this will be useful, this particular balanced equation that will be used for the quantitative analysis. And similarly, you can see many reactions, some reactions are reversible also. So in the case of ammonia formation, that N2 plus H2 gives NH3. So that reaction can be reversed if pressure and temperature variation of the catalyst, these conditions are changed. So now we are studying only about the reactions that are carrying out only in one direction. So if the products can turn back to the reactants, so such equations are called, or such chemical reactions are called reversible chemical reactions. Now let us look at the first activity. One more equation we will solve. So burning of magnesium below, Mg plus O2 gives MgO. So here you can see left hand side 2 atoms of oxygen and the right hand side only 1 atom. So in order to make that 2 oxygen atom, number of oxygen atom 2 over here, we need to add here 2. We can only change these coefficients only the left hand side. We cannot write here 2. So that will go wrong. The molecular formula of magnesium oxide is MgO only. We cannot write here 2. So take care, must not write 2 or the subscript or subscript. Then, so while doing so, what happens to the number of magnesium atoms? It became 2 over here onto the right hand side. But when you look at the left hand side, here only 1 atom of magnesium. So what we have to do here also, we have to write 2. So why we can't write here 2? Because magnesium is a metal which is existing in the form of monatomic. So we can write over here 2. So this simply means 2 atoms of magnesium or 2 moles of magnesium reacts with 1 mole of oxygen gas, so as to form 2 moles of magnesium oxide. And similarly, another equation, H2 plus Cl2 gives HCl. So simply, how can you balance this? Just you try. H2. 2 hydrogen atoms are here and 2 chlorine atoms are here. So what we need to put over the right hand side? Yes, we can put over 2 over here, so that on the right hand side as well as the left hand side will be balanced. So this 2 is applicable not only for hydrogen but also for chlorine. So that you keep in your mind. So onto the this side, you can see some homeworks I have given. So you just go through all these equations and write down it in your copy and balance the same. Okay. So first, N2 plus H2 gives NH3. The second one, CH4. that is methane plus oxygen gives CO2 plus H2O. Then the third equation, that is what we discussed, respiration. During respiration, cellular respiration, what is happening? Glucose using oxygen that decomposes so as to give carbon dioxide, oxygen and energy. So this particular equation, not oxygen, H2O, carbon dioxide, water and energy. And similarly, the fourth equation, H2S plus O2 gives H2O plus SO2. So this is another unbalanced chemical equation, so that you try to balance this equation. Then BaCl2 plus H2SO4 reacts to give BaSO4 plus HCl. Don't read just plus, okay? So and HCl. Then aluminium and chlorine reacts to give aluminium chloride. Then sodium hydroxide and HCl reacts to give sodium chloride and water. The next equation, potassium nitrate decomposes to give potassium nitrate plus oxygen. Then calcium carbonate plus HCl reacts to give calcium chloride and water. Then magnesium plus carbonate, magnesium and carbonate. Okay. Then magnesium oxide and carbon. Then calcium hydroxide and carbon dioxide gas reacts to give carbon dioxide, calcium carbonate and water. So here you can see calcium hydroxide. If you pass carbon dioxide gas through calcium hydroxide solution, what will be formed? Calcium carbonate as well as water. So these are some of the chemical equations. Just take a screenshot of this particular part and write down all these equations in your copy, and especially complete this homework. These homework questions you complete in your copy and you understand it well, and if you got any particular doubt, you can discuss with me in WhatsApp between the time 5 to 8. And also you can look at that page number 3. So balanced chemical equation. You read that particular part well, and also you follow the steps. How to balance the chemical equation, that is already given using different small steps. So you follow all these steps so that we can understand these things more. And you go to the page number 6, there you can see 3 questions are given. You try to do that particular questions as homework. Okay. And the next day we will discuss about the types of chemical reactions. Number 1, combination reaction, and the second, decomposition reaction, then displacement reaction, then double displacement reaction, then redox reactions. So mainly these 5 categories we will discuss in this chapter.